22 and a half hours. That is how long it takes for a single signal to crawl from the edge of known space back to a dish in California. 22 and a half hours of silence, of waiting, of a room full of engineers staring at a screen that refuses to change. And then, in the spring of 2025, it changed. A spacecraft that left Earth in 1977, a machine built with less computing power than a modern calculator, began reporting something that should not exist. Not a glitch, not noise, a structure. A boundary. A wall of heat sitting at the edge of everything we know, in a place where the models said there should only be cold and silence. For a moment, the people who have spent 5 decades listening to this one small machine did not know what to say. To understand why this matters, you have to understand what Voyager 1 actually is, out there, right now, further from home than any object built by human hands has ever traveled. It is not exploring anymore in the way we imagine exploration. It carries no camera that still works. Its scientific instruments have been switched off one by one, sacrificed to conserve the last dying trickle of power from a plutonium core that has been quietly decaying since before most of the people tracking it were born. What remains is a skeleton crew of sensors, a magnetometer, a plasma wave detector, a single particle counter, feeling their way through a region of space that no textbook fully describes. And it was one of these last remaining instruments, the plasma wave subsystem, that caught something engineers were not prepared for. The story of how Voyager 1 got here, to this exact point, to the very edge of the solar system's influence, begins with a boundary called the heliopause. Picture the sun not as a fixed point of light, but as the center of an enormous bubble. A sphere of charged particles blown outward by solar wind, pushing against the thin gas and dust that fills the space between stars. That bubble is the heliosphere, and its outer skin, the heliopause, is where the sun's influence finally gives way to the wider galaxy. Voyager 1's one crossed that skin in August of 2012, becoming the first human-made object to leave the solar neighborhood entirely and enter interstellar space. It took scientists more than a year just to confirm the crossing had happened, because there was no camera flash, no dramatic sensor spike, only a subtle change in the density of plasma around the spacecraft that took months of careful analysis to interpret. Voyager 1 was never supposed to still be doing any of this. Its primary mission was designed to last 4 years, a tour of Jupiter and Saturn, close flybys that returned some of the most breathtaking images ever captured of another world, the churning storms of Jupiter's atmosphere, the impossible geometry of Saturn's rings, seen edge on for the first time. Bolted to its side is a golden record, a copper disc etched with sounds and images meant to represent the whole of humanity, greetings in 55 languages, whale song, a human heartbeat, Bach and Chuck Berry pressed into the same groove, sealed with instructions for any intelligence that might one day find it, on the assumption that the machine carrying it would eventually go silent and simply drift, a monument more than a messenger. Nobody who built that record expected the spacecraft underneath it to still be transmitting data 50 years later, let alone data this strange. For years after that heliopause crossing in 2012, Voyager 1 behaved, more or less, the way the models predicted. It sent back a slow trickle of data describing a region far calmer and far colder than anyone had proof of before, because no instrument had ever traveled far enough to measure it directly. Every paper published in those years treated the heliopause the way a coastline is treated on a map, a boundary you could draw with a single confident line, gradual on one side, gradual on the other, nothing sharp enough to catch anyone by surprise. And then, quietly, without warning, the readings began to shift. In 2020, the spacecraft's magnetometer registered a sudden jump in the strength of the magnetic field surrounding it, while its instruments measured a corresponding rise in plasma density. Scientists had a name ready for this kind of event. They called it a pressure front, a kind of shockwave rippling outward from the sun, compressing the thin interstellar plasma the way a piston compresses gas in a cylinder. It had happened before, briefly, and then faded back to baseline within months. This time it did not fade. The elevated readings persisted month after month, refusing to return to the numbers the models expected. Researchers who had been confident they understood the shape of this pressure front began to question whether it had anything to do with the sun at all. One astrophysicist working on the magnetometer data described the source of these compressions as behaving like a piston, a steady mechanical push from somewhere, except a piston is supposed to retract. And this one seemed to be jammed in position, holding the surrounding plasma compressed far longer than any solar event on record. Something else, something not yet named, seemed to be shaping the environment Voyager 1 was moving through, an environment that was supposed to be one of the quietest, most predictable regions the spacecraft would ever cross. Some researchers began to wonder aloud whether the spacecraft had simply drifted into a distinct region within the interstellar medium itself, a pocket of denser, older plasma left over from events that happened long before humanity existed to measure them, a kind of fossil turbulence drifting through the galaxy on its own timeline, indifferent to anything happening around our sun. And just as that question was beginning to take shape in scientific papers and conference talks, the spacecraft itself very nearly stopped answering entirely. In November of 2023, the stream of data from Voyager 1 dissolved into gibberish. Not silence, which engineers could have worked with, but a repeating pattern of ones and zeros that meant nothing. A signal technically alive but functionally empty, like a phone call where the line stays open but the voice on the other end has been replaced by static. Somewhere inside the spacecraft's flight data subsystem, one of only 3 onboard computers still running after nearly half a century, something had broken. For 5 months, a team back on Earth worked through the problem with almost nothing to go on. No live diagnostics, no ability to simply plug in a replacement part, only the ability to send a command and then wait almost 2 full days to find out whether it had worked. Eventually they found it. A single memory chip, holding a small fraction of the subsystem's total capacity, had failed. But that small fraction happened to contain code essential to packaging the spacecraft's science and engineering data before it could be transmitted home. The chip could not be repaired, could not be swapped, could not be reached by any human hand ever again, sitting as it was on a circuit board 24 billion kilometers from the nearest screwdriver. So the engineers did something that sounds almost impossible on its own. They rewrote the missing code, broke it into pieces, and searched through the spacecraft's remaining memory for empty corners, where those pieces could be tucked away and still function as a coherent whole, like reassembling a shattered manuscript using blank margins scattered across a dozen different books, each fragment placed with the knowledge that a single mistake, sent across a gap that takes nearly a full day to close in each direction, could end the mission permanently with no chance to try again. There was no way to test the fix beforehand, no identical spare, sitting in a lab on Earth running the same corrupted code. Every command sent to Voyager 1 carried the full weight of that uncertainty. 22.5 hours to arrive, 22.5 hours more before any response could confirm whether it had worked. A full day and a half of silence for a single roll of the dice. On April 20th, 2024, the patch was uplinked. Voyager 1 began talking again, coherently for the first time in 5 months, from a machine so old that the engineers troubleshooting it had to consult documentation written by colleagues who had since retired or passed away, paper records and hand-annotated schematics from a program that predates most modern computing entirely. It was, by any reasonable measure, a resurrection. A spacecraft, pulled back from what looked very much like a quiet, undramatic end, one nobody outside the small circle of mission engineers would likely have ever noticed. It was only after this brush with permanent silence, after the spacecraft had been effectively resurrected from what looked like terminal data corruption, that the readings which had been building since 2020 sharpened into something scientists could no longer wave away as noise. Around the same period, researchers piecing together years of magnetometer and plasma data announced a finding that unsettled even veteran members of the mission team. At the very edge of the Heliosphere, in the region both Voyagers had now passed through, temperatures spiked to somewhere between 30,000 and 50,000 Kelvin. A wall of heat, invisible, intangible, sitting in a region of space so thin and so empty that classical physics says it has almost no business being that hot at all. The heat itself is not a mystery in the way you might first imagine it, not glowing, not radiant in any way a human eye or a camera could register. It comes from the sheer velocity of the particles themselves, individual charged particles moving so fast that their kinetic energy translates into a temperature reading far beyond anything in that region. Even though the particles are spread so thin that there is almost nothing there to burn, it is heat without fire, energy without light, a boundary made of speed rather than substance. For decades, the working models of the heliopause described a gradual, gentle transition, solar wind slowly losing its grip, interstellar material slowly taking over. What the two Voyagers actually measured was closer to a wall, a boundary far sharper and far hotter than the mathematics had allowed for. And this is the part that scientists still cannot fully explain. If that wall of heat is real, and the two independent spacecraft, separated by billions of kilometers and years of travel time, both measured something consistent with it, then every diagram, every textbook illustration of the solar system's edge, every model used to predict how our sun's bubble interacts with the rest of the galaxy, may need to be redrawn, not adjusted at the margins. Redrawn. Consider what that actually means for a field of study that has spent decades building its understanding of the heliosphere almost entirely from theory, simulation, and indirect observation, because until these two aging spacecraft physically passed through the boundary, nobody had ever been able to measure it directly at all. Every prior model was, in a sense, an educated guess, refined over generations of physicists, but never once checked against reality. Now that reality has finally answered back, And the answer does not match the guess. A boundary that was expected to behave like a gentle fade instead behaves like a wall, sharp enough and hot enough that some researchers have started describing it, informally, in language usually reserved for far more violent cosmic events. Nothing about it threatens Earth. Nothing about it is dangerous in any way that reaches back toward the inner solar system, but it forces an uncomfortable admission. The edge of our own cosmic neighborhood, the place we have called home for the entire history of our species, was never as well understood as the diagrams in school textbooks suggested. While researchers were still absorbing the implications of that heat boundary, Voyager 1's plasma wave instrument, the same sensor that had first confirmed the spacecraft's crossing into interstellar space back in 2012, began registering something else entirely. A faint, continuous hum, a low-frequency signal with no obvious source, not a solar flare, not a burst of galactic radiation, nothing that matched any known category of event. It had likely been there for years, too quiet to detect until newer signal processing techniques on Earth became sensitive enough to pull it out of the background noise. Scientists believe it originates from the diffuse plasma that fills interstellar space itself, charged particles vibrating gently the way sound waves ripple through air, except this sound has nowhere to travel, or no ear built to hear it, until a machine 49 years old happened to be passing directly through it. The significance of that hum goes far beyond its strangeness as a phenomenon. For the first time, scientists had a tool that could measure, directly and continuously, the density of the plasma filling interstellar space, something that had only ever been inferred indirectly before Voyager 1 arrived to listen. Earlier estimates of that density had been built from models and from faint second-hand evidence, calculations layered on calculations, never once confirmed by a direct measurement taken from inside the environment itself. The hum changed that overnight. Suddenly there was a continuous physical signal, faint but real, that researchers could point to and say, this is what the space between stars actually sounds like, not what we calculated it should sound like. As the spacecraft continues its slow crawl outward, at just under 17 kilometers every second, covering a distance every single day that would take a commercial jet almost 2 full days to cross, that hum is expected to shift and change as it passes through regions of varying density, effectively turning Voyager 1 into the only living instrument capable of mapping the texture of the space between stars in real time. Nobody planned for this. The instrument doing the listening was designed in the 1970s for an entirely different purpose, meant to study the sun's influence, not to become humanity's only working microphone pressed against the wall of the galaxy. And yet, here it is, decades past its intended retirement, doing exactly that, whether anyone designed it to or not. Put these threads together and a picture starts to form that is stranger than any single anomaly on its own. A pressure front in 2020 that refused to behave like the ones before it, a near-total data collapse in 2023 that very nearly ended the mission for good, patched together with code, stitched into the margins of a computer's dying memory. A boundary of extreme heat that classical models never predicted, discovered almost immediately after that resurrection. And underneath all of it, a hum from the depths of interstellar space that nobody was listening for until the equipment finally became sensitive enough to hear it. Individually, each of these might be explained away. A pressure front is, after all, just a pressure front. A computer chip fails, as computer chips eventually do. A boundary can simply be hotter than expected, without meaning something is fundamentally wrong with the models. But taken together, across the same 5-year window on the same aging spacecraft, they form a pattern that some scientists are reluctant to call coincidence. There is no leaked transmission here, no encoded message, no signal from beyond that anyone credible is claiming to have decoded, whatever certain corners of the internet might suggest. What there is instead is something arguably more unsettling in its own quiet way. A 50-year-old machine dying by inches, power failing year after year as its plutonium core cools, that keeps finding new ways to prove that the edge of our solar system is far stranger than anyone predicted when it launched. Every extraordinary claim about this spacecraft does not need embellishment to be worth taking seriously. The real data is strange enough on its own. NASA has already begun shutting down instruments to preserve what little power remains, a slow and deliberate process of triage, choosing which senses to keep alive and which to sacrifice as the spacecraft's plutonium heart cools by a fraction of a percent every year. The cosmic ray subsystem, once used to help pin down exactly where and when Voyager 1 crossed the heliopause, went dark in February of 2025. The low-energy charged particle detector is scheduled to follow before the end of this year. After that, only the magnetometer and the plasma wave subsystem will remain, 2 thin threads of data connecting Earth to the edge of everything, and even those are expected to fall silent by the end of the decade as the last of the spacecraft's power finally runs out. Which means the window for understanding what Voyager 1 has actually found is closing permanently in a way no future mission can simply reopen. There is no plan, funded, or even seriously proposed to send another spacecraft out to interstellar distances within the lifetime of anyone currently working on this project. The next generation of probes designed to study this region, still years from launch, will take decades themselves just to reach the boundary Voyager 1 crossed back in 2012. For a stretch of time that could last a generation or more, whatever secrets lie in that hot, humming boundary between our solar system and the rest of the galaxy will belong only to the fading whispers of a machine that was never meant to survive this long, transmitting from a distance so vast that by the time its signal reaches a dish on Earth, the words describing its discovery are already more than a day old before anyone reads them. Some scientists are cautious, insisting the heat readings will eventually be folded neatly into a revised but ultimately conventional model of the heliopause, that the hum is simply background plasma behaving exactly as background plasma should, that the 2020 pressure front and its long refusal to fade will turn out to have a mundane explanation once enough data accumulates. This is, after all, how science tends to work in the long run, strange readings absorbed piece by piece into a slightly wider theory, until what once looked shocking becomes just another paragraph in a textbook. Others are less certain, pointing out that every time Voyager 1 has approached a boundary, humanity assumed it understood. The spacecraft has returned data suggesting the boundary was sharper, hotter, or stranger than predicted, and that a pattern like that, repeated 3 or 4 times across 50 years, starts to look less like a coincidence and more like a warning that the map itself was wrong. Neither camp has enough data yet to close the argument, and neither is likely to get it soon, because the only source of new evidence is a machine that is running out of both power and time. What nobody disputes is the timing. A machine that almost went permanently silent in 2023, patched back to life through what amounted to a small miracle of remote engineering, immediately began returning some of the strangest data of its entire mission. Whether that is meaningful or simply the coincidence of an old spacecraft entering a genuinely unusual patch of space at the exact moment its last working instruments happened to be listening closely enough to notice, is a question that may never be fully answered, not because nobody wants to answer it, but because the only witness capable of gathering more evidence is dying 1 watt at a time, 24 billion kilometers from home, and there is no way to send anyone or anything out to relieve it before the silence finally becomes permanent. Somewhere in mission control, there is already quiet discussion about the day this stops entirely. The day the last command goes out, takes its 22.5 hours to arrive, and receives no answer at all. Nobody knows exactly when that day will come, only that current estimates place it somewhere before the end of this decade, a horizon that once felt impossibly distant and now sits uncomfortably close. When it happens, Voyager 1 will not stop moving. It will simply stop talking, drifting onward through the same hot, humming boundary it spent its final years trying to describe, carrying its golden record and its unfinished data into a silence that, this time, will not be patched, will not be resurrected, and will not send anything back at all. Whatever else lies out there in that boundary between our small bubble of light and the vast dark beyond it, humanity's only witness is running out of breath to describe it, and for now, nobody can say for certain how much more it will manage to tell us before it finally goes quiet for good.